Ever wondered how the future of computing looks like? Have you ever heard about quantum computers? We're standing at the precipice of a new era in technology, an era that promises to redefine our relationship with computers. This is the era of quantum computing. This is not just an upgrade or a new model. No, this is a whole new paradigm. It's like shifting from candlelight to electric light, from horse-drawn carriages to automobiles, from analog to digital. Quantum computers are not just faster versions of the computers we have today, they are a different beast altogether. They operate on the principles of quantum mechanics, the science that describes nature at its most fundamental level, the level of atoms and subatomic particles. You see, classical computers, the ones we use today, process information in binary bits, zeros and ones. But quantum computers, they use quantum bits or qubits. Here's where it gets mind-bending. A qubit can be both 0 and 1 at the same time. It's like flipping a coin, and instead of it being either heads or tails, it's both simultaneously. This is due to a quantum property known as superposition. And when you have multiple qubits, they can be interconnected through a quantum phenomenon called entanglement. This allows quantum computers to process massive amounts of data at once. So, what does this mean for us? It means that tasks that would take a classical computer millions of years to solve, a quantum computer could potentially solve in mere seconds. It means solving complex simulations, optimizing large systems, breaking or creating new cryptographic codes, revolutionizing artificial intelligence, and so much more. Quantum computers, with their qubits, promise to revolutionize the way we compute. We're just at the beginning of this journey, and there's so much more to explore. So fasten your seatbelts because the quantum revolution is here, and it's going to change everything. The world of quantum computers is fascinating, isn't it? But how exactly do these quantum machines work? Well, the answer lies in the mysterious and counterintuitive principles of quantum mechanics that underpin these advanced machines. Let's delve into it. At the heart of quantum computing are two fundamental principles: superposition and entanglement. Superposition, quite simply, is the ability of a quantum system to be in multiple states at once. To put it in perspective, imagine a coin spinning in midair. While it's spinning, it's both heads and tails at the same time. That's superposition for you. Now, when it comes to quantum computers, they leverage this principle to handle vast amounts of data simultaneously. Then we have entanglement, another strange yet crucial element of quantum mechanics. When particles are entangled, the state of one particle is directly connected to the state of another, no matter the distance between them. It's as if two entangled particles can instantly communicate across the universe. In the context of quantum computing, this allows for an extraordinary level of parallelism and speed in processing complex computations. But what does this mean for us? Well, the potential of quantum computers is immense. They can solve complex computations far quicker than the most powerful supercomputers of today. Problems that would take a classical computer millions of years to solve, a quantum computer could theoretically solve in mere seconds. From simulating the behavior of molecules to optimizing logistics and supply chains, the applications are virtually limitless. In essence, quantum computing is like venturing into a new realm of possibilities. It's like switching from black and white television to high-definition color. It's a paradigm shift that promises to transform our world in ways we can't even imagine. The principles of quantum mechanics bring a whole new dimension to computing, enabling quantum computers to solve problems beyond the reach of classical machines. So, buckle up as we journey further into the quantum realm in our next segment. So, we have a basic understanding of quantum computers, but what makes them so special? Well, for starters, their power. Traditional computers use bits which can be either a 0 or a 1, but quantum computers use quantum bits or qubits, which can be both a 0 and a 1 at the same time thanks to a principle called superposition. This allows quantum computers to process a massive number of possibilities all at once. Moreover, qubits can be entangled, another quantum phenomenon. If two qubits are entangled, the state of one immediately influences the state of the other, no matter how far apart they are. This interconnectedness can potentially speed up computations immensely. Now, imagine a problem that would take a classical computer thousands of years to solve. With the right quantum algorithm, a quantum computer could crack it in mere seconds or minutes. That's the power we're talking about. This quantum leap in computing could have far-reaching implications across a multitude of industries. Take cryptography, for example. Today's encryption methods could be broken open by quantum computers, necessitating the creation of new quantum-safe cryptography. In the healthcare sector, quantum computers could model complex molecular structures, fast-tracking drug discovery, and understanding of diseases. They could also potentially analyze vast amounts of medical data, identifying patterns that would otherwise go unnoticed. And let's not forget artificial intelligence. Quantum computing could significantly speed up machine learning processes, leading to faster, more accurate AI. But of course, it's not all rosy. Quantum computers are still in their infancy and there are significant technical hurdles to overcome. But the potential is there and the race is on to harness this power. Quantum computers have the potential to bring about a quantum leap in computing, solving problems at a speed and scale unimaginable with classical computers. As we venture further into this quantum realm, who knows what other incredible advancements we might discover? Quantum computers seem promising, but are they ready for prime time yet? As we venture deeper into the quantum realm, we encounter a few stumbling blocks. The first one is the difficulty of maintaining qubits. In the quantum world, qubits, the basic units of quantum information, are incredibly sensitive. They can easily be disturbed or lose their quantum properties, a phenomenon known as decoherence. It's like trying to hold on to a slippery eel. The tighter you grip, the quicker it slips away. Moreover, error correction in quantum systems is another significant challenge. Unlike classical computers where a bit is either a 0 or a 1, a qubit can be both simultaneously thanks to superposition. This makes error correction a complex task. Imagine trying to fix a mistake when you can't even be sure what the mistake is. But don't let these challenges dishearten you. Science has always been about pushing boundaries, and quantum computing is no exception. There's a flurry of research and development happening around the globe to overcome these hurdles. Scientists are exploring different types of qubits, such as topological qubits, which are believed to be more robust and less prone to errors. There are also advancements in quantum error correction algorithms, designed specifically to tackle the unique problems posed by qubits. So what does the future hold for quantum computing? Well, it's as uncertain as the position of a quantum particle. But one thing is sure, the potential is tremendous. Quantum computers could revolutionize fields like cryptography, material science, and even artificial intelligence. They could solve problems that are currently beyond the reach of even the most powerful supercomputers. Imagine being able to design new materials at the atomic level, or cracking encryption codes that would take conventional computers billions of years to solve. These are the possibilities that quantum computing could unlock. Despite the challenges, the future of quantum computing looks bright, promising to reshape the landscape of computing and beyond. Quantum computing, a fascinating world that marries the principles of quantum mechanics with the power of computing. We've embarked on a journey today, exploring this fascinating world, and it's time to take a moment to revisit what we've learned. Quantum computers, unlike their classical counterparts, leverage the principles of quantum physics to process information. They employ quantum bits or qubits, which, unlike the binary bits of classical computers, can exist in multiple states at once, a phenomenon known as superposition. This allows them to process vast amounts of information simultaneously, opening up possibilities far beyond the reach of classical computing. But it's not just about superposition. We've also discussed entanglement, a peculiar quantum phenomenon where qubits become interlinked, and the state of one can instantaneously affect the state of another, no matter the distance between them. This is a powerful tool in quantum computing, enabling a level of synchronization and speed that's simply unattainable with classical computers. Yet the quantum realm is not without its challenges. Quantum coherence, the delicate state in which qubits exist, is easily disrupted, leading to errors in calculations. The development of error correction methods and the quest for achieving quantum supremacy, where quantum computers outperform classical ones at a practical task, is an ongoing journey. But despite these hurdles, the potential of quantum computing is revolutionary. From drug discovery to climate modeling, from cryptography to artificial intelligence, the applications of quantum computing could redefine the frontiers of science and technology. As we continue to push the boundaries, to explore and innovate, we're not just observing a new paradigm of computing, we're actively shaping it. As we stand on the brink of a quantum revolution, one thing is certain: the world of computing will never be the same again.